Okay, now that we know the two major part of each compiler or interpreter are lexing and parsing, I want to show you a code that actually implements that, actually gets a code line by line. I have a code here. As you can see, like I have variables, different types, numbers or strings. I can assign values to it. I can do some operations on it. So every time gets a line of this code, do the lexing on it, do the parsing on it, and eventually runs it. And it just goes to the next line. That's what the interpreter does, right? So just a quick recap. So the lexing analysis is the first phase of any compiler or interpreter. The main job is to just read the source code, convert it to a meaningful stream of tokens, and then we pass that tokens to the parsing, and the parsing checks everything and make sure that everything is ready to be run. Usually creates a structure, like a proper structure with all those tokens that can actually pass on to the next phase, which is actually running. This is a structure that is called as a parse tree or syntax tree, which has each element of the tree is different element of the line, variables, values, operators. If you have parentheses, every detail of a line from the tokens. Now it's going to be sit inside the parse tree or a syntax tree. And now this tree will be passed to the next phase, which is actually going through the tree and running everything. All right, so created this class. I called it interpreter, and I have all these token specification. Like this is like a form of any variable. I have like patterns, regular expression for finding and assignment operators, for plus equal operators, for minus equal operators, for multiplication equal operator, any variable that comes after any of those operators, number values, string values, semicolon, space, and a new line. So for your assignment, basically you want to add more patterns to these. If you have for loop, other things, you just want to play with this and add more pattern to this. Okay, and then I have the constructor. I get the file name. I create like a dictionary of the variable. I initialize the dictionary of the variable, and I also want to keep track of all the lines, each line that I get from the input file. I want to keep track of all those lines. It has like a lexical analysis function, just one function that does lexing, one function that does parsing. I am not creating like a parse tree or anything at this point. So in my parse function, um, I just get the stream of tokens through this parameter variable. I just go through them, understand them, and run them all in the same place, all inside this function, just for the simplicity. Otherwise, I also have to talk about the parse tree and how we create that parse tree, which makes things more complicated. So, um, inside my parse function, I parse everything and run at the same time. Um, and then I have the run function that actually goes through each line of the input file. And then when it reads each line of the file, it does the lexical analysis. It gets a stream of tokens, and then it just passes it on to the parse function. Parse function actually understands it, checks it, and runs it. Does everything here. So when I run the code, well, I commented out this part in case you want to get the file name through the command line. You want to comment this one and uncomment this line. But I'm just hard coding the file name here. That's not you should do for your last assignment. You should get the file name through the command line. And then I create an interpreter object, and I just run the run function from this object. And since I'm not printing anything in this example, at the end I'm just printing the dictionary of the variables, all the variables and their values, so we can see actually this code works. Okay, so let me show you how the lexing work. Lexing is actually super easy now. So once you come up with the good patterns for each element of the code that will be appeared on each one of these lines. So for example, we have a variable and then equal sign and then like an integer value and the semicolon. Once you come up with a good pattern to detect those, so when we call a lexical analysis, it gets a line of the code, and then what it does is it goes through all these patterns and run all these patterns on that line one by one to see if it can find any matches. So we'll loop through all those tokens, all those patterns. We get the token type and we get the actual rejects, and we just compile the rejects, and now we have our rejects object, and then we just call the search function on the line, and if we find any matches, and if it's not a space or a new line, so we just get what was matched inside that line. We just get that and we just add it to the list of tokens. That's it. Super easy. You don't need to understand everything. You don't need bunch of loops. You don't need bunch of if conditions. Super easy. You just go through all the rejects that we have here. We just look for all of those in the line, and if we find that, we just add that to the stream of tokens, to the list of tokens that we have, and then we just return that, and then we just pass on this list of tokens to the parse one. And like I said, I'm just doing the parsing and running at the same time. So I just grab everything. So I just have a bunch of if conditions to just grab, okay, if it's an integer variable or string variable, let's get the operator, which is now is going to be an assignment. Let's get the value. And if the value is a number, so that means we need to convert it into integer. If it's a string, that means I need to get rid of the quotations. If it's anything else, that means it's going to be like another variable. So from the dictionary of the variables, I grab the value of that variable. And then based on what the operator was, I just do one of these. So if it just wasn't like a normal assignment, I just assign the value to that variable and I just update my dictionary of the variables. That's it. Very straightforward. Very straightforward. Nothing complicated. The hardest part here is that you need to come up with the good patterns. So now if you want to implement like a line that has a for loop in it, you need to come up with the good patterns that actually can detect the for loop and all the elements inside that for loop that might show up. If you want to do a print, so you need to come up with a good pattern for that, like what comes after the print, and everything. So once you come up with the good pattern, so you don't basically probably you need to make some very small changes on the parsing to just get it going, but nothing. You don't need to change anything for the lexing. You can actually use this code and just add more stuff to it and for your last assignment.